Hello everyone. This is a problem from moment of inertia. A wire of linear mass density lambda kilogram per meter is bent into an arc of a circle whose radius is r and which is subtending an angle 2 theta naught at the center. Calculate the moment of inertia of the circular arc about an axis passing through its midpoint M and the axis is perpendicular to its plane. So we will start by taking an element on this circular arc. This is the midpoint and the axis is passing through this point and it is perpendicular to the plane of the arc. This point is M. And let us say somewhere here we have the center of curvature. Now this distance is definitely equal to the radius of this circle. And if we join before that let us take an element, a small element, and let us say that this element is located at a linear distance x from the point M, and also this distance will be equal to r. And if this small element subtends a small angle d theta at the center, then we can argue that its length dl will be equal to r into d theta. Also, if we drop a perpendicular from the center on this length x, and if we argue that this angle is theta, then this angle will be definitely theta by 2. This angle is theta, this total angle. So this length, this half length, that is x by 2. This will be equal to r sine theta by 2. And so we can write the value of x now, which will be twice of r sine theta by 2. Also, dm will be linear mass density times the length of the element, which is r d theta. So we have everything ready, and next we are going to write the small moment of inertia of this small element. So di will be dm times x square, and if we substitute the values, I think we will get 4 lambda, 1 r square will come from x square and 1 r is here, so r cube, and then we will have a sine square theta by 2 and a d theta. So now this problem becomes very simple. We have to simply integrate this di within proper limits, and our limits of integration will be minus theta naught to plus theta naught, 4 lambda r cube sine square theta by 2 into d theta, and then use simple half angle formula of trigonometry. So let us take 2 lambda r cube outside and keep a 2 with sine square theta by 2 into d theta, and then use the formula for 2 sine square theta by 2. We know that this will be equal to 1 minus cos theta d theta minus theta naught to plus theta naught, and so on integration this will give us 2 lambda r cube and theta minus sine theta minus theta naught to plus theta naught. So on proper limits, on putting the limits, we will get 4 lambda r cube and actually this will be, after putting the limits, twice of theta naught minus sine theta naught. So twice I have taken out and multiplied by 2, which is giving us 4 outside. So 4 lambda r cube multiplied by theta naught minus sin theta naught. So that is the answer to this problem. You can have a look once. This is a nice problem from moment of inertia. Thank you very much.